Hello friends, welcome back to my channel Varteta Learning Platform, and today we are going to discuss about the shared PTR. This is again a smart pointer provided by the standard library in C++. And it was beyond C++11. After C++11, this one was available. And to use this shared PTR, you need to include the header #include memory. The name of the header where this shared PTR has been declared is memory, right? So this is a template based class, just like we discussed about the unique PTR. This is again the template based class shared PTR. And why this is used? Why this is useful? This is useful because this performs resource counting. Okay, what does this mean? We will cover. And the second thing is, just like the unique PTR, it also provides move semantics, right? You know that using the move semantics, you can start pointing one of the smart pointer to the existing memory area which was pointed to by some other unique PTR, right? Just like in case of unique PTR, you had two pointers, P1 and P2, and if you move the P1 to P2, then P1 will contain nothing, and this memory area will not be belonging to P1, but it will now start belonging to P2 if you move the P1 to P2. If you write like P2 is equal to move P1, that you might have seen in the previous videos of unique PTR. So that's what happens when we use this move. Okay, so the same thing, the move semantics are also available in shared PTR as well, which means in shared PTR as well you can perform this move operation. You can move one pointer to the other, right? The other pointer will start pointing to the location which earlier smart pointer was pointing to, and the ownership will change, which means the earlier pointer will not contain anything now. That will be of no use, right? So let's discuss about the resource counting. What is the meaning of resource counting? Suppose if you have a resource, it can be a memory area, right? And in this memory area, you might have placed some critical information, right? And this critical information should be available till the number of instances of a particular object are available, right? Suppose you have one object, suppose obj1 of class, say printer, right? So you have created obj1 of this printer. So you know that with your computer only one printer can be connected. So all the information related to this printer, suppose that is available in this memory area, right? So you know that only one printer is connected to your system, right? So no matter you create how many objects of printer, it is always pointing to the same printer. obj1 is pointing to the same printer memory area. obj2 is also pointing to the same printer. So the same printer area, same memory area where the printer information is contained, this is also pointing to the same memory area. And similarly, if you create the object 4, then also printer is same, which means that if you create 4 instances of the printer, suppose from Notepad, from Word, from Excel, from PDF, right? Take it that way. So these are the 4 applications using which you are trying to access the printer. So no matter if you are trying to print it from Notepad, if you are trying to print it from the WordPad, if you are trying to print it from Excel or PDF, you are using the same printer area, same printer, right? So the information about this printer should also be available to some unique area. So that unique area should be available till any of these objects are available, which means if Notepad is printing, then it's done. Notepad is done. But again, if any of these 3 objects are available which are pointing to this printer, or in turn which are pointing to this memory area which contains the information about the printer, in that case this printer area should not be destroyed, because if any of these is active, then it means that they are using it, right? So in this case we need to keep the resource counting, right? So how we keep it? When Notepad connects the printer, resource counting become 1. When WordPad contains connects to the printer, then it becomes +1. Then when the Excel connects to the printer, then it becomes +1. When the PDF connects to the printer, then again it becomes +1. So the total resource count becomes 4. Suppose Notepad is done, then what will become resource count? It will become 3. When Word is done, then it will become 2. When Excel is done, then it will become 1. When PDF is also done, then it will become 0. So once the resource count becomes 0, which means all the instances are done, then in that case, there is no use of this memory area. When someone will connect, then we can again allocate, right? So in the system, we have, the number of resources which are available, they are limited, right? So to make the memory area available for other resources, we should free this memory area, right? Because our system, you can see sometimes that your system is using lot of memory. So that is very bad memory management. If someone has not done this kind of, memory management or this kind of resource counting and maintaining this memory area according to the resource counting, then this memory area will still be available and will still be occupied, right? It will always be there. So it will be creating the scarcity of the resources, or you can say the scarcity for the memory resource for your computer, and your computer may slow down, your other applications may slow down, right? So for these kind of situations, this kind of implementation related to the resource counting is maintained, is done, right? So this is how the shared pointer has been implemented, right? So shared pointer contains the resource count, and at the same time, it uses the move semantics as well. We have already discussed about the move semantics. So it means that shared pointer class already has the move constructors, right? It has the move constructor. So when you create the shared pointer object, suppose you create shared pointer p1, right? And when you create p2 and assign p1, use the assignment of use the copy constructor, right? So if you use the copy constructor and if you use the assignment operator, in both cases, the resource count will keep increasing. In all cases, copy constructor and assignment operator. If you just create it like p4 and doesn't assign, then no RC count will be increased. Nothing will increase. Okay. So this is how it is maintained. So let us see the uses of this class, this shared PTR, which has been provided to us. So I have just opened this. Where is my? Yeah, this is online DBG compiler. So here I'm just going to create my application, my program where I will use the shared PTR. So I have just included this memory header, and now I'm just going to create a shared PTR object sp1, right? Before that, let me just create one pointer, integer pointer, new int, and let me just put like asterisk p is equal to 100. And now here I'm just going to shared PTR, and I'm just going to use int, and here I'm going to provide p. Okay, now I'm going to create another PTR int sp2, and here I'm going to use the sp2 sp1 copy constructor I'm using, right? And now I'm just going to create shared PTR int sp3, and here I'm using sp3 is equal to sp2. Okay, so here I'm using assignment operator, right? So what will be the resource count overall for this shared PTR object? It will become 4. Okay, sorry, 3, 1, 2, and 3, right? So it is pointing to this one. Now let me just print the value. You print asterisk p1 or sp1 or sp2 or sp3, everywhere you will get the same result. So let us run it. So sp1 you will get 100. If you run it with sp2, you will get it 100. Okay, sorry, this is semicolon which is missing. So if you run sp2, then also 100, and if you run with sp3, then also it will be 100. Okay, and now let's do one thing. Rather than using the assignment operator, let's use the move sp2, which means that I have used this sp2 to move to sp3. Now what will happen, the responsibility, the ownership of sp2 has been moved to sp3. So asterisk sp3 will print 100, asterisk sp1 will also print 100, but asterisk sp2 will not print 100. It will crash if I use sp2 here. But if I use sp3 and sp1 here, then it will not crash. So let us see. We have used sp3, so it will print 100 perfectly. We have used sp1, so it will show 100 perfectly. But if I use sp2, then it will not print, and when you will run the real program, it will simply crash. Right here it is not showing the crash, but when you will create your own program and you run it using the Visual Studio IDE, then you will be able to see a memory violation. Okay, so this is now clear that move constructor is also available in shared PTR, just like we had it in unique PTR, right? So now we are going to use this. We are going to use it for resource counting. Wherever we need to have the resource counting things, we will use it, right? So that's it for today's video, and before I conclude, I would request you to please like my videos, subscribe my channel, and please share my videos if you like it with your friends, and be with me. There are a number of other videos, there are a number of other playlists where we have covered other aspects like other programming aspects like socket programming. There is Windows programming videos. There are many videos available on my channel, and once I will be done with this few of the videos with C++ tips and tricks, there will be few more videos on DLLs, libraries that you can create in C++, right? So that we will discuss later on. So till the next video, we will discuss shared PTR implementation in the next video. So till the next video, have a nice day and bye-bye.